All right. So then we're going to start doing the volume of those. So that pink graphic organizer that I gave you guys yesterday, you may want to have that one out. Because we will be doing volume. So you're going to need to know your volume formulas. All right. Now, for most of these, you'll be calculating the volume of cylinders and cones. All right. So let's look at number 1 together. So we're first going to draw line segments for these points. So take a minute, plot those points, and make the 2D figure. So when you finish plotting the points and connecting all the points with line segments, you should get a rectangle. Now, it then asks us to calculate the area of said rectangle. How do I calculate the area of a rectangle? What's the formula? Length times width. So, what is my length? 3. All I got to do is count 1, 2, 3. That's your length. What's your width? 2. You just count up 1, 2. So we're doing the area is equal to 3 times 2. And that's just what? 6. We're going to say 6 units squared. So remember, area, it'll be units squared. Volume, it'll be units cubed. You could also do that too. But knowing the formula is also good too. So that's our area. Now, we're going to then draw the solid formed by the revolving region about the x-axis. So what happens is that it reflects across the x-axis. So these two top points will reflect over here. And since these 2 points are on the x-axis, they'll stay there. Now, since they're revolving, what's the base going to be? A circle. So this is going to form a what? The cylinder. So if we draw this, should look something like this. All right. Isn't the prettiest cylinder I've ever made, but there you have it. So now we want to figure out the volume of this cylinder. I just realized that we should have drew it on the bottom one. That's fine. So now we're calculating the volume of this cylinder. So what's the volume of the cylinder? What's the formula? It's on that pink sheet I gave you. How do you find volume of a cylinder? From yesterday? Landon, what you got? Right. So it's basically the area of a circle, which is pi r squared, with the addition of height. So pi r squared times height. So if I draw my cylinder, I'm going to draw it down here again, just so we can see it. So it looks something like this. All right. So there's my cylinder that I just redrew from this rectangle. So here's the rectangle in here. Now, I need two things. I need the radius and I need the height. Technically, we already have both. What do you think my radius is? 2. Why do you think it's 2? Right. So if we look right here, all right, here's the center of the circle. And remember, the radius is a segment from the center of the circle to the edge. If we count, that's 1, 2. So our radius is 2. What about our height? What do you think? So it may look weird because it's on its side, but if we turn that can right side up, what part of the can will represent the height? 3. So this part right here would represent your height, or this part, depending on what you look at. And both of those are 3 units long. All right. You guys see the similarities from the first one? What's the similarity? It matches the dimensions of the rectangle from this first problem. So in this first problem, it matches the dimensions we have here. So 3 and 2. We have a 3 by 2 rectangle. And then the cylinder it makes has a radius of 2, height of 3. So H is 3, R is 2. And then I'm just going to put it into the formula. So I have V is equal to 2 squared times 3 times pi. I want to slap pi on at the end. Because essentially, whatever, we can simplify the numbers and then slap a pi on at the end to get our most accurate answer. But then we can also put in our calculator to get a rounded answer. So what's 2 squared? 4. So this would be 4 times 3 times pi, which, what's 4 times 3? 12. So this would be 12 pi units squared. This is our exact, not units squared, units cubed. This is our exact answer. All right. Now, if we want a approximate answer, we can put it into our calculator and we're going to use the pi key for pi. So remember, we don't use 3.14 anymore because your calculator has the pi key. All you do is hit second and then the little caret key to get an exponent, and I'll give you pi. It'll input exactly pi. So we have pi times 2 squared times 3. That would be our approximate answer. So let's say we rounded it to, let's say 2 decimal places. What would it be? Right, so it'd be 37.70 or just 37.7 units cubed. So we had our real answer, and then we also had our approximate answer. I would take either one. But if I ask for the exact, leave it in terms of pi. If I ask for an approximate, put it in your calculator, give me a decimal. All right. Any questions on that? All right. Now we're going to do the same thing, but instead of rotating over the x-axis, we're going to rotate this rectangle over the y-axis. So in other words, this part's getting reflected. So when we do this, it'll look, and you guys can turn off the light if you need to. I know it's probably hard to see. So if we do that, our cylinder would look something like this. Again, not my prettiest cylinder, but good enough. So we're still doing the same formula for volume. Still doing pi r squared times h. So what's my radius this time? Someone besides Jasmine. You sure? Look at where the circle is. It's 3. So my radius in this case is 3 because I'm looking from here to here. What's my height? 2. So I'm looking from here to here. So we're still using the same 2 dimensions. They just flip-flopped. All right. So now the radius is 3 and the height is 2. And that does make a difference. So radius is 3, the height is 2. So if we put it in the formula, I have v is equal to 3 squared times 2 times pi, which what's 3 squared? 9. So I have 9 times 2 times pi. What's 9 times 2? 18. So I have 18 pi units cubed. So it's actually a bigger number than the previous one. Same numbers, but within different spots of the formula. Now, if I put that in my calculator to get an approximate answer, I do second pi times 3 squared times 2. If I round to the nearest hundredth, so 2 decimal places, what would I get? 56.55. Good. So this will be approximately 56.55 units cubed. So you guys understand how I'm doing this? You guys kind of get the pattern? So it all depends on which direction you're rotating. If you're rotating over the x-axis, your width becomes your radius and your length becomes your height. Whereas if you're rotating over the y, it switches. Your length is now your radius and your width's your height of the rectangle. So the dimensions don't change just because you rotate it. It just gets transformed into a new formula. Does that make sense? So let's think about this carefully. Why are these 2 volumes different? What's the biggest reason? So something to do with the exponents. Landon, what you got? Right, the radius and height flip, and the biggest thing, like Jasmine said, is these exponents. 2 squared is 4, whereas 3 squared is 9. So what happens is that R and H flip, and 2 squared is not equal to 3 squared. Because we know that multiplication is commutative, meaning we can switch any terms that we want and it would still give us the same answer. However, that square in the formula is what changes it. Because no matter what we do, 2 squared will always be 4, 3 squared will always be 9, and there's no changing that. All right, any questions on that one? All right, let's do one more. All right, let's do number 2, so on the next page. So take a minute, plot these 3 points. All right, we got the points plotted. So this forms a what type of triangle? It's a right triangle, and it's obviously a right triangle because two of our legs are on either the y or the x-axis. So, and we know the x and y axis is perpendicular. All right. Now, how do we calculate the area of a triangle? What's the formula? So what's the formula for the area of a triangle? So 1/2 base times height or base times height divided by 2. So you can either do 1/2 base times height or base times height divided by 2. It's the exact same thing. All right. So what is my base of this right triangle? 2. Your base is typically the bottom of your triangle or the flat part of your triangle. What's the height? 3. So right triangles are easy with finding the height because the legs, one would be the base, the other one will be the height. And then we don't have to worry about the hypotenuse. So if I do base times height divided by 2, I get 3 times 2 all divided by 2. So what's 3 times 2? 6 divided by 2, which is 3. So I get 3 units squared as my area. Now, we're going to do the same thing that we just did with the rectangle. So before I even draw this, if I rotate that triangle around an axis, whether it's the X or Y, what's it going to make? A cone. All right. So right triangle makes a cone. So I'm going to rotate it around the x-axis. So I'm going to redraw the triangle for reference. So here's my triangle. And then I'm going to rotate it around the x-axis. So that means that if you count from the origin 3 down, because we went 3 up originally, and then connect it to the other point, that's the first part of your cone, and then you just kind of have to draw a circle or a slightly condensed circle. All right, so your cone will look something like that. It's not the prettiest in the world, but there you have it. All right, so here's our cone. Now, volume of a cone. What does that formula sheet say a volume of a cone is equal to? So look at that pink sheet that I gave you. For a cone, what is it equal to, the volume? Guys, it's literally reading a piece of paper. What does it say? Good. So it's basically the volume of a cylinder times a third. All right. Another way you could think about it is pi r squared h divided by 3. That's another way you could think about it. All right. So just like last time, we need to find our radius and our height. So what do you think my radius is? It's definitely 3. So it comes from right here. And that is most certainly 3 because that's the part that connects the center of the circle to the edge of the circle. What about the height? Someone besides Jasmine, what do you think? Definitely 2. So the height would be from the center of the circle to the vertex of the tip top of the point of the cone. So this right here would be 2. All right, so I have a radius of 3, a height of 2. So if I put in my formula, I have volume is equal to 1/3 times 3 squared times 2 times pi. So let's break this down with what we know. What's 3 squared? 9. So this would be 1/3 times 9 times 2 times pi. Anyone know what 1/3 times 9 is? Same thing as 9 divided by 3. It's 3. So this would be 3 times 2 times pi. So what do you think my answer is going to be? 6 pi. Because 3 times 2 is 6, and then we just slap the pi on at the end. So 6 pi units cubed. Now, if you put that in the calculator, what do you get? So plug it into your calculator. You make sure you use that pi key. You just hit second and then the little caret key. And you can just do times 6 because we already know it's that. So what is my approximate answer? Round to 2 decimal places. So Corey, what'd you get? That's right. So 18.85 units cubed. All right, so I got my real answer and my approximate. All right. Try the next part on your own. So using the same triangle, but rotate it around the y-axis, and then calculate the volume. So take a minute and try it. So you're trying parts E and F on your own. So everyone's trying part E and F on their own. Okay, so I would do 4 times 3. Because then it gives you a number back.
I went to do it. Just confused me.
Yeah, do 4 times 3 first, because it doesn't matter what part you're doing it. I just almost. So did you draw it?
Yes.
Now find the radius and the height. The radius still 3?
Can you do 4 times 12?
Yep. But it's not the same as the previous one. All right, thumbs up if you're ready. You guys, 1 more minute. What's 12 divided by 2? So 4, 5.
I was trying to do 4 divided by 3 before I added.
Doesn't matter what order you do multiplication in, it's commutative. All right, you guys ready? So someone raise their hand and tell me what they got for, we know it's going to form a cone. Someone raise their hand and tell me what they got for the radius of that cone. Jasmine. It's 2. All right, so the radius is 2. Now someone else raise their hand and tell me what they got for the height. Maddie. 3. So it flip-flopped from the previous one, just like it did with the cylinder. Now, what'd you guys end up getting as your actual answer when you took the volume using those measurements? So your actual answer, not your approximate. Someone who hasn't talked yet. Haley. 4 pi. Good. And then what was the approximate if you put it in the calculator? Someone else. 12.57. Yes. Sorry, I thought you said 4 for a second. So yes, it would be 12.57. So you guys basically did exactly what I got. And again, why were those 2 volumes different? Did what? They switch, but what's the biggest reason? Has to do with one little tiny number. The exponent. So just like with the cylinder, 2 squared will always be 4, 3 squared will always be 9. So even though multiplication is commutative, meaning we can do it in any order that we want. It would still give us the same answer. Exponentials or exponents are not. They have specific values that they equal. 2 squared will always be 4, 3 squared will always be 9. All right, so that's why they're different. All right, any questions on any of this? So again, all this lesson is can you plot a shape on a graph, rotate it around an axis, and recognize what type of shape it'll be, and find the volume of that 3D figure. All right. So really, you only need to know that a rectangle gives you a cylinder, a triangle gives you a cone. That's the only two that you need to know. All right. Any questions on any of that? All right. So there's a Delta Math and a quizzes on this. All right. So the quizzes is quick. It's just asking you what it looks like when you rotate it. The Delta Math actually has you put it into action. All right. So we'll continue practicing this tomorrow too. So if you don't get through all of it, that's okay. Just pick one and go with it. And I'll go ahead and post the Excel ticket as well. So it's hard to see, but it's also posted in Canvas if you can't see it. And just draw a quick sketch of the shape that it makes, or the shape that it comes from.